Hi, good morning. We're going to be talking about Chapter 8, which is solutions, uh, oral medications in liquid forms. So, the thing that you should know about solutions is there are strengths in solutions, and strengths would always come as a fraction. There are pure forms of the drug, and there are diluted forms of the drug. Once you dilute the form of the drug, the strength goes from 100% into a different lower percentage. So pure forms will be the numerator of your fraction, which represents the pure drug. It's 100% concentration or full strength with no diluting agents. If a pure form is a solid, the label is in grams, like acetaminophen or something that's tangible powder. If a pure form is a liquid, the label is in milliliters, which is like hydrogen peroxide or boric acid or something that is already liquid. When you dilute it, it's going to be the total volume is going to be represented in milliliters because you're reconstituting from a powder to a liquid form, and the denominator of the fraction will be the total volume, which is the diluted form of the pure drug plus the solvent to form a total solution. All diluted forms are in milliliters. So, the strength of a solid drug in a solution would be the amount of pure drug per total milliliter of solution. For example, if we take coffee and you have 3 grams of coffee, that's a very small amount of coffee. But if you add 240 milliliters to the coffee, your concentration would be 3 grams for every 240 milliliters. If you have a bottle already, you see the strength fraction there. It says 10 milligrams per milliliter, which means 10 milligrams is what the actual drug is over 1 milliliter for every 1 milliliter of that solution. If you have a pill or a solid and you're going to reconstitute it into a liquid, the pure form of that drug in that pill is going to be, say, 5 grams. The diluted form would be in 100 milliliters of water. So you wouldn't say that this is 5 grams and 100 milliliters. Instead, you would say this is 5 grams in a 100 milliliter solution. The reason why you can't say this is 5 grams and 100 milliliters is because if you think about when you drink coffee and you have the hot water or the hot coffee already made and you add sugar to it, the coffee rises a little bit, so you would have more than that original amount in there. So what you do is you add the dilutant in order to get 100 milliliters total versus adding the pill or the powdered form into the liquid. You would add the liquid into the drug. So you can't add grams in milliliters to get, like, say 105 milliliters because it doesn't necessarily go up by that much. You would say 5 grams in 100 milliliter solution. So the strength of the drug in the solution with the amount of pure drug per total milliliter of the solution. If you are talking about milliliters and milliliters, you can say there is 1 milliliter of pure drug, and then I add 39 milliliters of dilutant to make a 40 milliliter solution. This one here, I could tell you exactly how much dilutant is added. So 1 milliliter of acetic acid plus 39 milliliters of distilled water would make 40 milliliters of acetic acid solution. Since they both are measured in milliliters, we can add or subtract to see how much dilutant is added. The percent strength would be the amount of drug per 100 parts of solution. If you think about percent, you would think about 100 always. If you get 100% on an exam, you're like, that's right, I got 100. I got everything right. If you get anything lower, then there's a percentage of that 100 that you're getting correct. So anytime you see percent, you're going to put that over 100. So this first example says 35% of NaCl. NaCl is a sodium, which is a solid. So you would say that there are 35 grams for every 100 milliliters of solution. Since this is a strength fraction, you can also flip it and say there are 100 milliliters for every 35 grams of NaCl. Again, if you were talking about acetic acid, the 35% wouldn't change with the strength. It would still be 35 over 100, but your labels would be a little bit different. For example, this here would be 35 milliliters of acetic acid, since it was originally a liquid in its purest form, over 100 milliliters of total solution. I can also say in 100 milliliters of total solution, I have 35 milliliters of pure drug. If you notice, when I label that milliliters over milliliters with dimensional analysis, you automatically want to cancel them. In order not to cancel them, whenever you have milliliters with milliliters, I would label them with solution to pure drug. And the reason for that is now you won't just eliminate them, because obviously if you have a solution, it's different than the pure drug. But before I wrote the word solution and pure drug, it wasn't obvious to me that they would not cancel, because they just said milliliter and milliliter. So the strengths of solutions can be represented as ratios, fractions, and percents. When you get the strength of a solution given as a ratio, a fraction, or percent, we're going to make them into a strength fraction with labels of pure drug and total volume, and then show the strengths possible for each strength fraction. So for example, if I have 5 over 20, that tells me that the strength would be 5 grams of pure drug for every 20 milliliters of solution. Or I can flip it to say, oops, my bad. I can flip it to say 20 milliliters for every 5 grams of pure drug. Now, if that 5 wasn't in grams, say it was a milliliter of pure drug, then I can also say 5 milliliters of pure drug to 20 milliliters of solution. Or I can say in 20 milliliters of solution, there will be 5 milliliters of pure drug. So for any of these three, whether it be a fraction, a ratio, or a percent, I can represent them with milliliters or with grams of pure drugs. I'm just going to show you the other ones. With ratio, it says 2 to 5. So you would say 2 to 5, and you would have grams per milliliter, or 5 milliliters to 2 grams. Likewise, I can change the grams to milliliters, and I can say 2 milliliters pure for 5 milliliters total solution, or 5 milliliters total solution to 2 milliliters of a pure drug in liquid form. And then the last thing we have is percents. As we did earlier with the 35%, this time it says 45%, so I'm going to put 45 grams for 100 milliliters, or I can say 100 milliliters for every 45 grams solution. Again, you can also flip them to say 45 milliliters, but remember to label with pure drug versus the solution. That way your milliliters don't automatically cancel right out. So now I want you to try to write the strength of the following example as a percent, ratio, and fraction. To me, it's the easiest to write it as a fraction because I know that it's going to be the pure drug to total volume. Or, I don't like to use the word volume, I like to use the word solution. Because those are the words that you're going to see later in your word problems. So if we have pure drug to total solution, the amount of pure drug in here, it says part solute, which is pure drug, is 1. So we'll say 1 part is pure drug. To total part solution, we have 1, 2, 3, 4, 5 parts of the solution. Notice how even the part of the pure drug counts as this total solution. So my fraction would be 1/5. My ratio would just have dots in it, so it would be 1 to 5. And my percentage would just be 1 divided by 5 times 100. And we have to times it by 100 because that would put it into percents. And you would get 20%. Awesome? Okay. So right here, if we write the strength of the following examples as a percent, ratio, and fraction. I want you to pause the video and see if you can do this. And then when you unpause it, you can see if you've done it correctly. All right, so it says, give the strength or concentration of medication containing 15 milliliters of a pure drug mixed with 35 milliliters of water. What I'm saying is my strength fraction would be pure drug to total solution. So when I read the problem here, it says 15 milliliters of pure drug, so I have that 15 milliliters on top. And then it says it's mixed with, and here's the tricky part, mixed with 35 milliliters of water. It didn't say total solution, so it's just the water. So I have the 15 milliliters pure plus the 35 milliliters of water to obtain a 50 milliliter solution. So my strength fraction would be my 15 milliliters pure to 50 milliliters of solution. I'm going to make some more room for myself here. And when I have that, then it says 15 over 50 would be the fraction. If I reduce that, I'm going to divide each by 5, and I get 3 to 10. That's my fraction. My ratio then would be 3 to 10, and my percentage would be 3 divided by 10 times 100. So I would get 30%. So there's my fraction, my ratio, and my percent. All right, the next one says that there are 70 grams of drug dissolved with 140 milliliters of solution. What is the strength of the solution expressed as a fraction, ratio, and percent? Again, I always do fraction first, so I would have the pure drug to total solution. And when I look up here, I have 70 grams of a drug dissolved, and here it is, in 40 milliliters solution. So since it's already the solution, I would have 140 milliliters there. So my fraction would be 70 over 140, which would really be 1/2, or 1 to 2, or 1 divided by 2 times 100. So it's a 50% solution. Give the strength or concentration of medication containing 15 milliliters. Oh, we just did that one. Perfect. I'll cut that right out for you. That was easy. All right. So the last thing that I want to show you on this page is a lot of times in medicine labels you'll see this strength written as a fraction, and then you'll see in percent or in parentheses it written as something different. If I were to be given an order in milligrams, I would use this. And if I were to be given an order in grams, I would use the 0.2%, because 0.2% really represents 0.2 grams, because it's a percent, out of 100 milliliters. Then the actual question here asks you to verify that the two strengths are equivalent. So verify that the two strengths are equivalent, which means that this should be equal to this. So this blue one we did here with the 2.2 grams over 100 milliliters, I'm going to see if it equals 2 milligrams for every 1 milliliter. In order to do that, I have to get this gram to equal milligrams. So if I have 0.2 grams and I want to put it into milligrams, then I have to change it so that there are 1,000 milligrams for every 1 gram. And doing dimensional analysis and multiplying, I see that that is equivalent to 200 milligrams. So I can change this to 200 milligrams. And I'm not going to change milliliters because this milliliters is already milliliters. So over 100 milligrams. And when I divide each by 100, I get 2 milligrams for every milliliter. And that can verify now that this is equivalent to this. And medication labels have been approved by the FDA, not FDA, the USP, and they have already done all that math to make sure that those are correct. So instead of doubting the medicine labels, you can say, you know what? I'm going to either trust that if the doctor gives the medicine in milligrams, I'm going to use this dose, and if they give it in grams, I'm going to use this dose in order to make my strength known for my dosages. All right, so here you are looking for 3 parts in each of the following questions that will be necessary for you to come up with the correct setup for your answers. You will be given a strength of your solution expressed as a ratio, percent, or fraction. You should put this strength in fraction form, label pure drug and total solution, and write down both options for the strength. Let's do step 1, and then we'll go see what step 2 says. The first question says, how many grams of a drug should be needed to prepare 1 liter of a 1 in 5 solution? My first step, again, if you could recall, says we'll be given the strength expressed as a ratio, fraction, or percent. Here I see the ratio as 1 to 5. And it says to make this a strength fraction labeled with pure drug and total solution. So I can say 1 to 5, and the 5 is total solution. And the 1, I'm not sure if it's grams or milliliters. The way to tell if it's grams or milliliters is I look, and if I see the word gram anywhere in there, I know that this would be grams. If I did not see the word grams anywhere, then I would know that it was a milliliters to milliliter solution. So it does say to express this as a fraction both ways. So I can say either 1 gram to 5 milliliters, or I can say 5 milliliter solution to 1 gram of pure drug. The next step says you should underline the question being asked to see if you are looking for pure drug or total solution. Your key word here is solution. So we're going to underline it until I see the pure drug, here it is, and the word after it, I do not see the word solution. So I am looking for pure drug. So it says you should label your answer with that, what the question is asking. So I'm going to say grams, pure drug. And then it says start your setup with the same label you want your answer on the top of the strength fraction. So if I want my answer in grams, I have to start with grams on top. So I'm going to start with 1 gram to 5 milliliters. And that's my start. So that's number 2. Then step 3 says set up your next fraction with units to cancel in the numerator. So times with milliliters here because I had to cancel those milliliters there. And the second fraction should have a 1 in the denominator. Notice how I have not looked at the problem yet because I don't know what I'm looking for to set up my problem with until I get this, set my solution up until I get this far. So right now, I know I need milliliter solution, so I'm going to read this and find out where I can find milliliter solution. And this says that I'm preparing 1 liter of a solution. So 1 liter is 1,000 milliliters. So I can say 1,000 milliliters here, which is what I want because this milliliter will cancel with this milliliter. And I would be left to do the calculations to get 200 grams of pure drug. That was a lot, but it was good. There's 3 steps. The first one was to set up the strength fraction, and then it was to multiply, and then it was to underline to see if the word solution was after the pure drug. In this case, it was not, so I knew I was looking for the pure drug. So therefore, I labeled my answer grams of pure drug and started my strength fraction with grams. And then I multiplied it by the amount of total solution so that the solutions canceled, and I got my 200 grams of pure drug. If I want to think about it further, what this answer tells me is that there are 200 grams for every 1,000 milliliters. Let's see if we can get some room here. I really didn't leave a lot of room for myself, did I? Okay. So now, like I said before, this would mean that there were 200 grams. Check. There are 200 grams, that's the pure drug, for every 1,000 milliliters of solution. And I have to see if that is equivalent to my 1 to 5, which I had. If I times 1 by 200, I get 200, and 5 by 1,000, I get 5 by 200, I get 1,000 as well. In order to tell, I could also plug it into my calculator and say 200 divided by that is 0.2. And if I did this in my calculator, 1 divided by 5 is 0.2. So since they check, I know that I got the correct answer. Now I want you to read the next question, pause, try to set it up, and then come back and see if you did it correctly based on what that question is asking. I am going to keep going. So this says here, how many grams of dextrose are contained in 30 milliliters of this solution? My first problem, my first way to solve this problem said that I should set up my strength fraction. So my strength fraction, I could either use 50% or I can use 25 grams to 50 milliliters. I'm actually going to use the 25 grams to 50 milliliters because it's already in a fraction for me, and I'm not going to reduce it because I have a calculator. But I am going to write it in two ways. I can say either 25 grams are in 50 milliliters or 50 milliliters are in 25 grams. Then my second step says to underline the problem. Oh, I knew it was grams. Oh, I knew it was grams because of this too. So I'm going to underline the problem until it says the drug, which happens to be the sugar. And it does not say solution here, so I know that I'm looking for grams for my answer. So I'm going to start with grams on top of my strength fraction. Then the last step says I'm going to multiply with something with milliliters there. And that goes over 1. And then I'm going to look back up here and says contain 30 milliliters of a solution. And since this was a solution and this is now a solution, then I can cancel out my milliliters and do the math on that. If I do the math on that, then I'm going to get, we're pretty far off, 15 grams of a pure drug. So I can just say 15 grams. All right. Awesome. Again, you can pause it and come back. And the best part about this is if you're still confused, you can always rewind and watch it again. So what I'm going to do is move on to the next problem. And the next problem says how many milliliters of a 20% magnesium sulfide solution will contain 40 grams of magnesium sulfate. What I'm going to do is first set up my percent fraction, or my strength fraction, using the percentage that I'm given, which is 20%, so it's going to be 20 over 100. And I have to look to see if there's grams or milliliters. So when I go back to read this whole thing, I'm looking and looking and looking, and oh, I see grams. So grams tells me that there are grams to milliliters, or 100 milliliters to 20 grams. Then my second step says, go to where the question is asking. It says how many milliliters of a 20% magnesium sulfate. That's the drug. But this time it says the word solution. So we're looking for milliliters solution. Which means I'm going to start with my strength fraction of milliliter solution on top. So I'm going to say 100 milliliters to 20 grams. And my last step says I'm going to multiply it with grams on top to cancel with grams on the bottom, over 1. And I look up here, and that's good because the pure drug is 40 grams of magnesium sulfate. It did not say solution, so I knew that that was the pure drug, and I'm going to have 40 grams there. When I do my math calculations, my answer is then 200 milliliters of that solution. Make sure you label. All right, the last one on this page here says there are 5% mannitol irrigation. Just kidding. The last one here says how many milliliters of mannitol solution shown will contain 2 grams of mannitol. So my first step said that I had to make the strength as a fraction, percent, or ratio. If I look here, there are 2 ways I can find the strength. This is the first way. The easiest way for me is 5%. So it would be 5 over 100. And to figure out whether the 5 is in grams or milliliters, I reread the question, and it says, how many milliliters of the mannitol solution shown contain 2 grams of mannitol? So I know that this mannitol is in grams because it's a solid, so I'm going to write grams there. And I'm going to write the fraction in 2 ways. Now, I said that there were 2 ways that you could find the strength. That was one way, and then if you can read that really small label, it says each 100 milliliters contains mannitol 5 grams. So, you can find it either way that way. And then the second part of this, the way to solve these is it says to underline the question being asked, how many milliliters of mannitol, and see if the word solution is after the name of the pure drug, and it is. So therefore, I'm looking for milliliter solution. So I'm going to start with milliliter solution on top. So I'm going to start with 100 milliliters of 5 grams and times it with grams on top with 1 on the bottom. When I do that, I have to look back in my original, how many milliliters of mannitol showed 2 grams. So I'm going to say 2 grams. And that 2 grams of mannitol, it did not say solution, so that was the pure drug. So I can cancel out grams. And I have 100 times 2 divided by 5 to get 40 milliliters of the solution. Every 40 milliliters of that solution will contain 2 grams of mannitol. Now these were pretty easy because they had grams and milliliters, and grams would be a solid and milliliters are a liquid, so that's very distinct which one's the pure drug and which one's the total volume. However, we're going to start to milliliters conversions, and when I look here it says how many milliliters of a 1 in 40 acetic acid solution will contain 25 milliliters of acetic acid. So the way that I know that this acetic acid is a liquid is because liquid acid is actually a liquid. But if I didn't know that, also I don't see the word grams anywhere in that. So since I don't see the word grams anywhere in that, I'm going to assume that it's a milliliter. And remember, the only difference between milliliter and grams is the pure drug is either in liquid or solid form, so the strength doesn't change. So the first thing I'm going to look for is a ratio, percentage, or fraction, and I see this ratio is 1 to 40. So I'm going to say 1 milliliter pure to 40 milliliters total solution. And notice how I did label the pure in solution, because if I didn't, I would just want to cancel the milliliters and milliliters out. Or I could say 40 milliliter solution to 1 milliliter pure. The second thing says to underline until you get to the pure drug, which is acetic acid, and see if the word solution follows it. And in this case, it does. So I'm going to start with the solution on top. So I have 40 milliliter solution over 1 milliliter pure drug times it by milliliters pure drug over 1. Then I'm going to look up here and see that there are 25 milliliters of acetic acid. It does not say solution after the word acid. So I know that that 25 milliliters is pure, which is good because that's what I labeled it with. So I can cancel with that on the bottom. When I do the calculations, I get 1,000 milliliters. What? That is awesome. So the next one I'm going to do is how much hydrogen peroxide would you need to prepare 300 milliliters of a 2/3 strength hydrogen peroxide solution for wound irrigation? So what you're going to do now is find, the first thing says you're going to find the strength as a fraction, ratio, or percent, and I would have 2 to 3 then. The bottom is always milliliters. And the top one, I have to figure out whether the drug, which is hydrogen peroxide, is a liquid or a solid. There are 2 ways that I can find that out. Peroxide I've used before, so I know it's a liquid. Or I can look through there and I don't see any grams ever, so I know that this is also milliliters. But because they're both milliliters, now I have to label them pure versus solution. Or I can say 3 milliliter solution to 2 milliliters pure. The next thing says I'm going to underline until I get to the drug, and then it does not say the word solution afterwards. So I'm looking for the pure drug, so I'm going to start with that pure drug on top. So I'm going to start with 2 milliliters pure hydrogen peroxide over 3 milliliters total solution. And I have to multiply it by some kind of milliliter solution over 1 as my second step. The third step is I'm going to find out what they give me, and it says I'm going to prepare 300 milliliter of the hydrogen peroxide, and the word solution is there, so I know that the 300 is a solution, and I can cancel that by using dimensional analysis. So I have now 2 times 300 divided by 3 would be 200 milliliter pure hydrogen peroxide. Okay, the last one I'm going to do for you today will be this one, and it says, how many milliliters of a 1/4 strength Sestical solution can be made from 12-ounce can of full-strength Sestical? So what I'm going to do is the same thing that I have been doing in this 1/4 here. I'm going to put 1/4 milliliters, and then I'm looking to see whether it's going to be milliliters or gram, and since it's a Sestical solution, I'm not sure if it's milliliters or gram. But when I look here, it says how many milliliters of a solution can be made from 12-ounce can of Sestical. So the thing is this says a 12-ounce can. If it's in a can, it's going to be that. It's like Similac. Well, I guess Similac is gummy powder too. This one's going to be milliliters to milliliters. It's going to be milliliters pure to milliliters solution. Or I'm going to say 4 milliliter solution to 1 milliliter pure. So I'm going to underline the first, and it says how many milliliters of a 1/4 solution. So I need solution on top, so it's going to be 4 milliliter solution to 1 milliliter pure times milliliter pure over 1. That's going to give me my total solution that I need. But however, all I have is a 12-ounce can of full strength. Because it says full strength, it's the pure form, so I know I have pure, but this says ounces, and I need to get it to milliliters. So I'm going to take my 12 ounces and form it into milliliters. And we know that there are 30 milliliters in an ounce. So this here number would be 360 milliliters. And that's my pure, because it's full strength. Because I can now cancel out my milliliters pure with my milliliters pure, I can multiply the numbers together and get 1440 milliliters. Okay? Now I want you to try, oh no, let's accept that. Now I want you to try the your turn part. And after you try the your turn part, I will post the notes on D2L so that you can review how you did it, because I don't want to do that right now. I want to make sure that you know what you're doing at this point. Just be mindful, and if you get confused, then you can just go back to the steps. Make your strength fraction first, then underline to see if you see the word solution, or if you don't, then you know that you're looking for the pure drug. Then you can use that strength for the setup and fill in the second fraction with a 1 in the denominator. Cancel your units and solve. All right, this was chapter 8 on solutions. The next thing we're going to do is concentration of mixture problems. Good luck.